So basically this whole lesson 2, we're going to be doing some rounding and we're going to be practicing with the zeros like yesterday. But it's time to simplify it a little bit and write less. Aren't you ready for that? Okay, so in order to round to the nearest 10,000, I have to look at the digit in the 10,000s place, but I'm going to circle the digit to the right of it. So that tells me that I have 4 10,000s. What number is that?
40,000.
40,000. What comes after 4 10,000s? 5 10,000s. So what number is that?
50,000.
50,000. Now, you remember the strategy of just put a 5 on the end? We can't do that. We can't put a 5 on the end of 40,000. So what are we going to do, Sadie?
45,000?
45,000. We've got to actually put a 5 in place of the first zero we see. So this is a little bit different than decimals. Okay? So now my number is 48,000. So above or below the midpoint?
Above.
And if I circled that 8, I already knew it was going to be above. Did you already know it was going to be above?
Yes.
Okay, so my answer? 50,000. Write this down. You're not going to use these number lines anymore the rest of the day.
Yeah.
Okay, so you write it down for me now, and you get to skip it the rest of the day. So the next one is the thousands place. So I'm going to box everything up to the thousands place. Okay, I'm going to end up looking at the 6 to decide which way it rounds. And all these other digits, look at this, are going to change to 0 after the box. So that's what goes on the bottom of my number line. 48,000. What comes after 8?
9.
So 49,000 goes at the top. I know I'm going to put a 5 in there somewhere, Tucker. Where am I going to put the 5 for the midpoint?
495.
In what place value?
In the hundreds.
In the hundreds place value. Good job. I hear you. I have to train myself. Thank you, Lainey. She's raising her hand. I knew I made a mistake. There we go. Okay, so I'm rounding 48,600. Up.
Above. Above.
Above. So to the nearest 1,000, it rounds to 49,000.
Yes, it does.
Okay, nearest 100. So I box everything up to the hundreds place. 48600. And I'll end up looking at the 2 to decide if I round up or stay the same. So what I wrote down here, 48,600 goes on the bottom of my number line.
48,700.
7 comes after 6. Jay, what's the midpoint?
48,650.
48,650. Okay. My number is 48,625. Above or below?
Below.
And I already knew that because I circled the 2. Right?
Yes.
Okay. So that one rounds, or it stays the same. We sometimes say rounds down, but it really doesn't go down. It stays the same. Okay. Next one, nearest what? 10. Okay, so I'm going to box everything up to the tens place. 4862, and the 5 changes to a 0. So that goes on the bottom of my number line. 48,620.
48630.
48,630. Sadie wants to say the midpoint.
48,625.
Oh, that number looks familiar. That's the number I'm rounding. Do I circle the midpoint?
Yes.
No. What do I do?
You circle the number at the top.
It goes up.
Because
Good.
5 and up always goes up.
Good. Okay. Next page. This is where we're going to take yesterday's lesson and we're going to combine some steps. I've had enough writing. I've had enough parentheses. Don't you feel the same way?
Yeah.
Okay. So all we're doing is we're breaking apart. It's called factoring. Okay? We're breaking apart the numbers that end in 0. We're going to take out the 0, figure out which power of 10 it is, and then just multiply it. So this is all I want you to write. 31 times 2 times 10. And do I want this little caret here?
Yes.
Yes, I do.
What here?
The one that I took from the 20. It reminds me a little bit of a number line. Okay, so now I'm going to do 31 times 2, which is 62 times 10. What's my answer?
620.
620. Yeah, much less writing than yesterday. Okay, which number am I going to factor here?
40.
The 40. It's 4 times,
10.
okay,
23 times 4 times 10.
good. Now, 23 times 4, you can use the standard algorithm for. Hayden, are you writing these? Because I don't want to get to the problem set tomorrow and have you not understand what we're doing. So what's the answer? 92 times 10.
920.
Good. What do I factor out of this one?
The 30.
A 3 and a 10, good.
10.
I can do 32 times 3 in my head because there's no regrouping.
96.
96, I'll do 2 times 3 and 3 times 3. So the answer?
960.
960. How is the second row different, Maite?
There's more zeros.
There's more zeros, so I'm going to have to do 2 sets of factors, okay? So the first one, I'm going to take out a 31 and a 10. You agree?
Yes. Yes.
And the next one, a 2 and a 10. No parentheses today. We're just going to rearrange things. So I'm going to rearrange, and I'm going to combine when I rearrange. So I'm going to do 31 times 2 times 100. Where'd my 100 come from?
10 times 10.
10 times 10. So I did that in my head before I rewrote it.
It's 62.
It is 62.
6,062.
62 times 100. Don't skip steps when we're just starting, okay? Okay. So now Maite says the answer is 62 hundredths, which is
6,200.
Okay, the next one.
23 and 10.
23 times 10 times 4 times 10. Is there anyone who's confused?
No.
So Daniel, I'm going to go ahead and take 23 times 4, but when I combine these two 10s, what do I get? 100. So I'm skipping that step of writing 10 times 10, like we did yesterday. 23 times 4, I already know what the answer is.
900.
So I have 92 hundredths, which is
9,200.
9,200. Okay, let's do the next one.
32. 10.
How'd you get 9,200?
Right here, Hayden. I did 23 times 4, which is 92,
Oh,
times 100. I forgot to write my last step. I just did it in my head. Okay, if I combine the two tens, what does it end up being?
96.
100. Good. So 96 times.
Those are easy.
Yeah. We could still keep going and add more zeros and use the same strategy. Okay, this is a really good problem right here. Okay, looks like I already got you started, but I want to read the problem and then we're going to talk about it. It says Jonas practices guitar 1 hour a day for 2 years. Bradley practices the guitar 2 hours a day more than Jonas. So how many total hours does Bradley practice? 3 hours. Okay. So 3 times as much as Jonas. How many more minutes does Bradley practice the guitar than Jonas over the course of 2 years? Okay, so we got several things going on. Number one, we got to figure out how many hours, who practices more?
Bradley.
So he's going to be down here on this tape diagram. Jonas is up at the top. He seems like a slacker only practicing 1 hour a day, but my goodness, how many hours would that be in 1 year?
that would be 365.
365 hours.
Unless it's a leap year, then it would be 366.
Okay. So we're just going to go with a normal year, not a leap year. Okay? Good point, Hayden. So this is 1 year, and I barely left myself room to write, but that's 1 year. 365 what? Hours. Okay? Bradley, over the course of 1 year, practices 2 hours a day more. So a total of how many hours a day?
Total of 3 hours a day.
3 hours a day. And we haven't figured it out yet, have we? So 365 hours
Times 3.
times 3. Now, here's what I was thinking. I was thinking, I'm going to multiply this times 3, and I'm going to take it times 2 for 2 years. But then I thought, wait a minute. Why would I want to work with those huge numbers when I can figure out an easier way to do this?
So you just do 365 times 3.
You're close.
Divide. No.
What's the difference between the two boys' practice time?
2.
These 2 extra boxes, right? Mm-hmm. So instead of multiplying times 3 and then multiplying times 2, why can't I just figure out the difference and then take it times 2 for 2 years? This is 1 year. The difference between their practice time in 1 year, Julian, do you know the answer to 365 plus 365?
Plus 365.
670.
I'm going to do times 2. Whoops.
I already figured this out.
Times 2, just to double check Channing's math.
730.
You're close. 730. So the difference between the 2 boys in 1 year, okay? Bradley practices 730 hours more a year. But that doesn't answer my question, not even close.
It's minutes.
Well, first of all, do you think we should do times 2 to get 2 years? Or do you want to save that to the end?
Say that to the end.
Well, there's really no right way to do it.
How about we just take the answer and multiply that by 2?
Okay, so 730 times 2 would give us 2 years, right? Why am I doing it like this?
Because Bradley practiced.
So that's what I get when I multiply that times 2. So this is more in 2 years. That's hours, though. How do I change hours to minutes? And don't shout it out. Let everyone think for a minute. Here's the real question. How many minutes are in an hour?
60.
So, how am I going to change hours to minutes, Blair?
Okay, hours to minutes. Hours to minutes.
You're close. If I divide by 60, my number's going to get smaller.
Multiply.
And I know I have more minutes.
Multiply by
So I'm going to multiply by 60. Now let's do that strategy we practiced today, just for the fun of it. Break these apart. So if I factor out a 10 here, what does that leave me? What does that leave me? 146. If I factor out a 10 here, what does that leave me? 6. Rearranging this, I'm going to do 146 times 6 times what?
Times 100.
Times 100. Did you write that?
Yes.
Okay, so now, standard algorithm, what do you think?
Yeah.
I can do it in my head. I'm going to do 6 times 6, what is it?
26.
36. Remember that 3. I'm going to do what? 4 times 6.
24.
24 plus 3.
27.
And I'm going to do 1 times 6
6. 8.
plus 2 times 100. Now, if you wanted to do 1/4, whoops, I'm sure I'm writing numbers wrong today. 146 times 6 using the standard algorithm, there's no rule that says you can't do that. That's fine. And that's probably, you're going to probably have a better chance of getting the right
We're
answer.
gonna write the 1 and the 100 on the bottom. Up there. Oh.
Thank you. So my answer to this problem is how many more minutes does Bradley practice over the course of 2 years? 87,600. 600 minutes. That's a pretty good problem right there. Okay. Now, let's talk about today's lesson. Go ahead and put your pencils down for a minute. So this is kind of an introduction to get us ready for what we're doing. I usually use the grocery store as an example of how to estimate how much money I'm going to need. This one's using the school. So it says contextualize, which means think about it, visualize it, okay, put it into words. Estimation using the population. What's population?
How
many? How many? Okay. How many kids in the classroom and the school? So let's start with 5th grade. Okay? Okay, we're going to use 5th grade, and then we're going to use HES, which is grades what? Pre-K through
6th grade.
Okay. So the first thing I have to do is look at this class.
There's about 20.
About 20. Do we have 17? Quit doing that with your pencils. Do we have 17 in here or 18?
Like 1, 2, 3.
I think it's 17.
16.
So
18.
18.
16.
Do we have 2 people absent today?
Anna and Faith. No.
We have.
Can we just stop? We're going to call it 17. That's what's in my grade book, okay? 17, I'm going to round. What would I round 17 to?
20.
20, just like Maite said. We have about 20 kids in this room right now. To figure out 5th grade,
Multiplied by 4 classrooms.
multiply by 4 classrooms. So in 5th grade, we have about 80 students, okay? And that's 5th grade. Pre-K through 6, how many grades is that? 8 grades. Because we have 1 through 6 plus 2 extra. And so we're going to assume that's 8 grade levels, right? And what are we going to multiply that 8 times? 80. So the total number of students in Huguenin Elementary is about what?
640.
Okay, that's the lesson today, basically. We're going to estimate, which means round first, then multiply.
Oh, I thought we were learning how much kids are in our grade.
No, that was just an example. Now, I'm not sure what the teacher who made this file was thinking when she just put the answers on here, but I'm just going to cover them up. Who was that teacher?
You?
I know. I really don't know what I was thinking. Okay. So the first 3 problems, we're going to do a little bit of estimating. Now, what did I say you have to do first in 5th grade? Round. So I'm going to round to my highest place value. I'm going to use a little bit of the same strategy we used before when we had the number lines. So I'm going to box my highest place value. And I'm going to look at my 5 to decide if I go up to the top of the number line or stay the same at the bottom. Okay, so Maite says 456 rounds to 500. And what about 42? Round it to what? 40. The 2 says it stays the same. So write that down. Now, what am I going to actually do underneath here? 5 times 4 times
1,000.
1,000. Why do you say 1,000?
Because I added up all the
You counted the zeros, didn't you? These are my minions. Just kidding. My monsters. You know you're my monsters, don't you? Says it on the door. I'll close the door when you leave so you can see. All right. So 5 times 4 is what? 20. So my answer to this problem is?
20,000. 20,000.
That's all we're doing today in math class. We have 6 total problems. Let's keep going. So I'm going to box my highest place value and circle the one to the right. So would this be 4,000 or 5,000? 5,000 times 40. Same problem except for, right, there's an extra 0. So I have 5 times 4 times what this time? 10,000. You know, those of you who are just copying down what I'm writing and not actually keeping up and thinking about this are not going to know what to do. 20 times 10,000. The easiest way to do this is just count my zeros. So 1, 2, 3, 4, 5. So the answer is
200,000.
200,000. Okay? Keeping with the same strategy, I already know what this rounds to. I just did it. What was it? 4,560 rounds to what?
5,000.
5,000. And what am I going to multiply it times this?
400.
400. Okay. Now, let's just see if we can get a little closer to the actual. Instead of 400, I'm going to keep one of my numbers the same. So go ahead and write 420 there. Trust me on this. I mean, if I'm going to the grocery store and I want to buy one more thing, wouldn't it be better if my estimates were closer to the actual? Yeah. Okay, so how would I do this problem then? I'm going to take out a 5 and a
4.
5 and a what?
2.
42. And then how many zeros do I have left? 10,000. Okay. Now 5 times 42. I might have to do standard algorithm, but I'm still going to be closer. And this is easy standard algorithm, right? What's the answer? 210. So I have 210 times 10,000. 1, 2, 3, 4, 5. How many total zeros?
6.
1, 2, 3,
5.
4.
Oh, 5. I thought you were adding 1 and 5.
That's okay. 1, 2, 3, comma. 1, 2, 3, comma. Now, when I watched the video this morning, Dwayne said, doesn't matter which way children do it. It's their preference. If they want to keep one of these numbers the same, if it ends in a 0, you can do that, right? Or they can round to the highest place value. It doesn't matter. Which one is going to get a closer estimate?
The close thumb.
Right. If I would have done it the other way, it would have been 2 million. This would have been 2,100,000. So it's a little bit closer. Okay, let's take a look at the next ones. Pretty much the same thing. Yes. So I'm going to round to the nearest thousands place, box it, circle the number to the right. I want you to get used to doing this. Okay, so will this be 1,000 or 2,000?
1,000.
1,000. Times
80. 90.
90. 8 tells me to round up, doesn't it? So that's pretty simple. I'm going to write a 9 with how many zeros?
4.
4.
4 zeros.
Pretty simple.
And then,
Okay, let's take a look at the next one. I'm going to box the 1, circle the 3. Is it going to be 10,000 or 20,000? 10,000 times, box the 8, circle the 8. 900. This looks familiar. How many zeros? 6. Got to be able to count.
9 million.
9 million.
I want that amount of money.
I think we all do.
I
Okay, the next one. Should we try and get this one closer?
Yes.
Let's do. So let's keep 880 the same. All right? So I'm going to round 3,120 to what?
3,000.
3,000. The 1 tells me to stay at 3,000. Times 880.
8,000,000.
Okay, so now let me rearrange this. I'm going to take 3 times 88 times a number with 4 zeros.
10,000.
10,000. 3 times 88. You want to use standard algorithm? Go ahead. Okay, So 264 times 10,000. Don't say the answer. Write it down. Put your 4 zeros on. 1, 2, 3, comma, 1, 2, 3, comma. And what's the answer? How do you say that?
2,640,000. 264,000.
No. 2 million.
64.
It's not 64 anything.
640.
640,000. Okay, that's the lesson. Tomorrow we'll do problem set and exercise.